In this video, we're going to talk about 7-segment LEDs, which you see right here. And we'll also talk about more about arrays. All right, 7-segment LEDs, each one of these segments is a separate LED. And each one is assigned a letter. So this top one here is A, this is B. Next one down is C, D, E, F, and the one across is G. This is shown in your lab book too. Okay, now, if you look on top here, you can see the pins of the 7-segment LED, and this says G. So that means that this particular pin is connected to segment G, which we said is right there. And by the way, they're not in order. So this one is F. This one is the common. I'll talk about that later. This is A, B, and so on. And then there's also pins down here as well. This one, by the way, is the decimal point DP. We're not going to use that. All right, now, when you're using the LED that we have in class, you're going to have to consult the spec sheet, which is in your lab book, and this shows it right here. And first of all, the pins are on the side of the 7-segment LED, and you can see from this diagram how they're numbered. So they go 1, 2, 3, 4, 5, 6, 7, and then pin 8 is on the bottom across from 7, and then it goes up 9, 10, 11, 12, all the way up to 14. Now this one, B, is the particular 7-segment LED that we have. Okay, so you have to use this particular column. So that means pin number 1, which is this one in the upper left-hand corner, goes to segment A. They're calling it cathode A. This one goes to F. This one is the common anode. 4 and 5, there's no pin there at all. This is the decimal point. We won't be using that. EF, no connection. CG, no pin. B, and then also another common anode. You can use either of these two, doesn't matter. Okay, let's go back to the simulation here. All right, now, whoops. To wire this up, what you need to do is make sure that each segment has its own current limiting resistor, its own 330 ohm resistor. So, for example, this one is G, and we have a resistor between G, and then there is a wire that goes from the other end of that resistor, up here, and that goes to one of the ports. So when you're wiring this up, that's the way you have to do it. You have to go from the particular segment, you got to have a resistor, and then from the resistor, a wire that goes to the port. Furthermore, pin A here, segment A, has to go to pin 2 on the Arduino. And then segment B goes to pin 3 on the Arduino. And then this one goes to pin 4. So they've got to be in order. Okay, 5, 6, 7, and then 8 right here. The common anode is going to go to port 9 on the Arduino. So starting with A, that goes to 2, B goes to 3, C goes to 4, and so on down the line till you're finished. And then the common anode goes to 9. By the way, you don't need a current limiting resistor on the common anode, just on the individual segments. Okay, now what we have here is a push button switch, which you'll need to wire up. I'm not going to use it on this simulation because I'm not going to show you exactly the code for the assignment that you're going to use, but you will have to wire up a push button switch, and there's information on how you have to use this. It actually makes use of what's called an internal pull-up resistor on the Arduino. So what that means is that you don't have to bother using an additional resistor when you wire up this switch. So when you're ready to wire up, you can see exactly. It's very easy. Just one side goes to a port 12 and the other side goes to ground. Okay, let's look at the code. All right, now, first of all, I've got this array here that's called digits. Now, this array is referred to as a two-dimensional array. And we call it that because it's, I have a separate array for each digit, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then each array element is in itself an array. And these numbers here contains the codes that will light up the particular number. All right, so let's just take a look at 0 for an example. All right, now on 0, you have to light up this segment, this segment, this segment, this segment, this one, and this one. The only one that you don't light up is G. Okay, now you can see here is the code for 0. So we have a 1 for segment A, 1 for segment B, C, D, E, F, but a 0 for G, and then this final 0. These are all zeros, and that's for the decimal point because we're not lighting that up. All right, if you look at 1 here, 1, to light up 1, you only have this segment and this segment lit. So therefore, A is out, B and C are on, and all the rest are off. So you can trace the rest of these if you want to check them, but they should all be right. All right, now we have another array down here, which I'm calling segment pins. And these are the ports that we're using for each of the individual segments. And those ports are from 2 up to 8. So you're going to have a separate array for that. And this is the display pin. This is the one that goes to the common anode. And that's going to be 9, port 9. Okay, now the code for the program itself. We have it set up here. We do a serial.begin. Not going to use that for this particular program here. But then we have a for loop, and the for loop is used to configure each one of those ports 2 through 9 as being 2 through 8, sorry, as being an output port. And 9, we just do that separately because we call that one display pin. Okay, now we go through the main part of the program, the loop. We have a for loop. Okay, so this is going to go through 0 to 9. And every time it executes this loop, one of the numbers is going to light up. So it's going to light up, and you'll see it in a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it's going to go back to 0. Okay, so we have to turn that display pin on because this is a common anode 7-segment LED, which means that anode here must be high. And we call on this particular function that we're calling set segment, and we pass to that function the number. So this is the loop control variable here, n. And then we have a 1-second delay so that we can distinctly see each number. All right, now here's where the work is done, and it's really very simple here. This is the function set segment, and you can use this exactly the way it is in your program. And what this does is it uses another loop control variable here that's called J, and it goes from 0 to 7, and we have a digital write, and so this gives it the segment pin. So in other words, this is going to be, it's referring to this array up here, and it's going to address this port 2, port 3, port 4, port 5, and so on. And then for each one of the ports, we're going to say digit sub n. N is going to be the particular number that we are lighting up. So if we're starting with 0, then n here would be 0. So it referenced that first element of this array. And then J is the thing that's going to vary. So it's going to go through each element of the array, and it's going to light up that particular segment or not light it up. So it's going to be 1, 0 is going to be 1, 1, 1, 1. All these are going to be lit except for segment G. And then, of course, decimal point is 0. Okay, let's try it out. Okay, so there you have it. And on your particular assignment, you're going to be doing the binary die assignment that we did before, that when you press this push button switch, you're going to get a particular number that's going to be displayed on the 7-segment LED. But you've got most of the code that you're going to need to do that. You're going to need all of this, which you can just copy and paste. Well, I guess you can't copy and paste from the video, but you might be able to do it from the lab book. And then you're going to need this set segment, and then the code in the loop here is going to be what you're going to have to create for yourself. Just one other thing before I end this video, and that is when you are wiring this up, be very careful with the resistors so that the two legs of the resistors do not touch each other. Because if they do, it's going to short out that particular segment and it's not going to light up. So you've got to be careful. It's not difficult to wire this up, but you do have to do it with some care to make sure that things don't get shorted out.